We've developed a technology that is built, that is spread entirely on the organization's infrastructure, and is providing things like multi-factor authentication or micro-authorization, I'll be talking later, in transit. So there is no need to be updating these applications, but we can do it live. And so it doesn't matter that the application is an administrative panel provided by one vendor or the custom-tailored application built internally. It just doesn't matter. We do not modify applications. We just put ourselves in a position where we can observe, analyze, and modify traffic to these applications. And yeah, FIDO2. So we can enable FIDO2 in minutes. And a picture is worth 1,000 words. So let me show you something. So this is a typical web applications with the password default. So the users log in with passwords only, and obviously this makes them vulnerable to a variety of attacks, leading to account takeover. And let's change that with Sequence. So let's assume Sequence is already run in the organization, and we've created this representation of this application inside Sequence. So that was just step one. There are 3 steps that needs to be done. In step 1, we create this virtual host inside Sequence. In step 2, we do it's a one-time process. It's a learning phase. So Sequence will try to figure out how this application is built without knowing the technical details underneath. So we don't know the tech stack behind this app. We only observe the network traffic and how the application changes on the front end, in the DOM. So it's obviously no such user exists in the target app, but that was sufficient for Sequence to be gathering data. So once Sequence is fed with data, we apply that knowledge. And you can see that as a default method, we've set to FIDO U2F, currently FIDO2, and look what's happening. The same user that used to log in with password only would now be required to provide an extra factor of security. So that's exactly the same key that Google uses within their own infrastructure. So